Hello everyone, today I'm not with you of course, my voice is very croaky, so today I'm going to use this app to help you teach next unit, so please follow with me and do as I ask you to do. First of all, you're going to go to Desmos and you are going to type in the equation. It'll come up on the screen very shortly. Now if you type this in as you see it, it'll allow you to, there'll be a button that underneath the y equals a sine bx plus c plus d, there'll be an a, b, c, d and an all button. Just tap the all button and your screen will look like this. Now what you are then to do is, this is a general science sine wave. Now the most important part is that you will notice that it completes one cycle here. This is the period. Sorry for the colour, I didn't bother changing it. I suppose I better change it. Do it in red. Alright, that's the period between there and there. You'll also notice that this value right here is actually, do it down here a bit more, it's actually 6.28. And that equals 2 pi. Therefore, the sine curve does one complete cycle in the value of 2 pi, which equals 360 degrees. That's very, very important to remember. Now, once you have done that, once you've got that sorted out, it'll always be 2 pi, and currently it'll always start at 0. And this value right here is actually just pi, because that's equal to 3.14. Now, next thing I want you to do is I want you to go to your Desmos, and then I want you to start moving the sliders as I'm about to show you. Now, if you move the slider A to the value of 2, you will notice that it went from the value of 1, and it's now gone to the value of 2. So it has increased. That's pretty shocking, isn't it? Oh, I better get rid of that. I better type it nice. It's increased the amplitude to 2. More importantly, it didn't change anything else on the graph. Didn't move the graph left to right. It didn't change the x-intercepts. It only moved it that way. Very important. Now, the next step is I want you to move the A value back to 1 again, and next we're going to investigate the value of B. Once you've moved A back to 1, move B to 2. You will notice that the amplitude has now gone back to 1. Okay, it's now gone back to 1. But now, the period has been halved. So this is now just pi. Or, as I tend to say, you now have 2 cycles. So this 2 matches that 2. So if you move the B to 3, you should get 3 cycles in the same time as 2 pi. So the B value tells you how many complete cycles you will have in the value of 2 pi. So if you moved it to 4, you would get 4 cycles. As you can see here, I've got 4 cycles in the value in the space of 2 pi. Okay, 4 cycles in the value of 2 pi. So the B, it basically shrinks the frequency. Now, we haven't used that word very much, but the number tells you how many cycles. Okay, The next step, what I want you to do is I want you to move the b back to 1 again, and then we're going to investigate what happens with the value of c. Now this time, as you've moved the value of a back to 1, b back to 1, and c has now gone from 0 to 1, you want to notice that it no longer starts at 0. It in fact has moved it to the left, the value of 1, which happens to be the same value as c. Now we call this a phase change, or a phase shift. So the c value just moves it left to right. If c is positive, it goes to the left. If c is negative, it goes to the right. So see what happens if you make c now become 2. And as you would expect, it's gone from 0 down to -2. So far what we've done a, oops, get rid of that, don't want that. A moves it up or down. It doesn't move it up or down. It's in amplitude. B makes it as the number of cycles in 2 pi. C moves it left to right. Now we have one final thing to do, and that is D. Now D is a constant. Any idea what D is going to do? Well, before we check it out, make sure C goes back to 0. Now, as you can see, all that's happened this time is the entire graph has moved up the value of 3, which is exactly what you'd expect, because since D is the constant, it becomes the y-intercept. Alright? So it just moves every value, with remembering it was like this. So now everything has been moved up the value of 3. So there you have it. We have y equals a sine bx plus c plus d. Each of these parts here change the shape of the graph, but each are independent of each other, which means one does not really affect the other. So what I'm going to ask you guys now is, now what we're going to do, if I said to you, I'd like you to figure out what this one would be. Y equals 2 sine 3x plus 2 plus 1. Straight away, you know that's the amplitude. So it'll go from -2 to 2. This part here will be the number of cycles, 3 of them. That'll be 2 pi, or 6.28. Says my 3 cycles. Still go from 2 down to -2. The plus 2 here is going to move it to the left. So my phase shift is 2. Which means now it does this. And that's at -2. And then the plus 1, moves up 1. So now our graph will look like this. Or something like that anyway. So that'll go up to 3, and that will come down to -1. So let's go try it in Desmos and see if we are correct. As I predicted, we have 3 cycles. It goes from 4 to -1. It's moved to the left by the value of 2, but it's a bit harder to see because we've got this 3 cycles, so it's actually moved it only 2/3. That distance there is only 2/3. See if you can figure out that one. And my amplitude has gone to the value of 2 as well. Because there now is my new mean line. Okay, with that in task now, I'd like you to go have a look at exercise 5.3, and I'll tell the teacher which questions is basically the questions where you have to try to use and graph them by guessing what they look like. So have a look at exercise 5.3 and have a go at that. Thanks a lot. Hope to be there tomorrow.